Our experiment is Schmitt trigger using IC MUA741. Okay. Aim of the experiment to verify the operation of Schmitt trigger using op-amp and to measure UTP and LTP, where it has UTP means upper threshold point, LTP means lower threshold point. We have to measure the upper threshold point and lower threshold point. With respect to that, plus VSAT and minus VSAT, that means plus saturation voltage, and that means positive saturation voltage and negative saturation voltage of the square wave output. Okay, our components required for Schmitt trigger op-amp, that means op-amp component name as MUA741. Okay, and resistors are 10 kilo ohm. We need two resistors. Sorry, here it is one resistor. No, it will be two number resistor. Okay, here we can use two resistors, 10 kilo ohm and 10 kilo ohm. CRO for the output screen, signal generator for the input, and power supply for to generate the square wave output. Okay, this is the circuit diagram for Schmitt trigger. This is the op-amp and these are the op-amp connections, and here mainly in op-amp the important point is 741 connections. That means 7th and 4th and 1st terminals connections are very important while connecting op-amp connections. That means if here we can see that 7th pin. Okay, here we can see 7th pin. For 7th pin on op-amp, that must be plus VCC, that means plus 12 volts, and for 4th pin it must be minus 12 volts. That means if by mistake if 7th pin is connected to minus 12 volts and 4th pin is connected to plus 12 volts, then the op-amp will be damaged. That means the op-amp may burst. Okay, and that op-amp not be used for other circuits. Okay, the op-amp will be totally damaged if the voltage sources will be if the voltage sources is inverted. So while connecting op-amp connections, first we need to connect the 7th terminal as plus 12 volts and 4th terminal as minus 12 volts, and this Schmitt trigger we can also call as inverting circuit, because in invert here minus, that means second pin is called as inverting input and third pin is called as non-inverting input. That means here we are connecting input signal to the non-inverting terminal, that means second pin of the op-amp. So we can also call it as inverting circuit or inverting comparator. Okay, inverting comparator, and the positive terminal is connected in between the resistors and one terminal of the resistor is grounded. So here we can observe that the 6th terminal is the output of this op-amp, and the output of that op-amp is again given back to the comparator with the non-inverting terminal. So it also called as positive feedback of the op-amp. Okay, here it can has different names as Schmitt trigger, non-inverting comparator, or positive feedback comparator. We can also call it as positive feedback comparator. Okay, this is the op-amp connections, and here we can give the 20 volts peak to peak and 1 kHz frequency as input signal to the non-inverting inverting terminal of the op-amp, and positive terminal, that means non-inverting terminal is connected in between the resistors, which is acts as a feedback terminal, that means feedback loop of this Schmitt trigger. So we can connect the circuit in MULTISIM software, and we can observe that output waveform which will be resulted. Here the input waveform as a sine wave waveform and the output waveform as a square wave waveform, square wave output waveform. Here we can see that output waveforms like this. This is the input waveform which I given to the circuit, and this is the output waveform which I got from the circuit. Okay, here plus V out, which is equal to the plus V sat, that means the saturation voltage, and minus V out, that means this is the negative voltage, that means minus V sat, that means negative saturation voltage. What is meant by saturation voltage and what is meant by that means what is meant by plus V sat and minus V sat. Minus V sat. Here we can see this is the plus V sat and this is the minus V sat. That means the positive, that means the highest positive peak of the square wave output waveform is called as plus V saturation. The negative output waveform of the negative peak of the square wave output waveform is known as minus V sat. That means negative saturation voltage. And what is meant by UTP and LTP? That means upper threshold point and lower threshold point. Upon combining both input waveform and output waveform, then we can observe that the square wave output waveform will exactly intersect with the input sine waveform. Then the output waveform and input waveform both are intersect at a point above the reference line. Then that intersect point is said to be upper threshold point. After upper threshold point, the sine wave waveform will be rejected and remaining waveform will be converted into the square wave output waveform. Okay, and similarly, if the negative peak of the output waveform of a square wave and the input waveform of a sine wave both are intersected at a point in the below the reference line, then that intersection is known as LTP, which is a lower threshold point. After the lower threshold point, the sine wave will be rejected. Hence, we can get the values of UTP, LTP, and plus V sat and minus V sat. With using of these four voltages, output voltages, we can draw the input and output transfer characteristics of a Schmitt trigger. By drawing input and output transfer characteristics of Schmitt trigger, we can find the hysteresis voltage for the Schmitt trigger. What is meant by hysteresis voltage? Hysteresis voltage means that the difference between upper threshold point and lower threshold point is known as hysteresis voltage. That means here we can get the VUTP, that means upper threshold point. Here we can get the lower threshold point. The difference between this upper threshold point and lower threshold point will give the hysteresis voltages. And this hysteresis voltage resulting waveform will be like this. This is the inner of this rectangular form, that means this x-axis. Here we can note that this is the LTP point and this is the UTP point. The difference of these two between the resulting will be this line, this x-axis. Okay, this is the UTP minus LTP. This is an hysteresis voltage. Okay, this is the hysteresis voltage. Let us see the connections on multisim software and run the circuit diagram, and let us see the output of this Schmitt trigger. Okay, let us open the multisim software. Yeah, this is the workspace to connect the circuit diagram, and go to the place component and select basic and select resistor. I need 10 kilo ohm resistor, so I am searching for 10 kilo ohm resistor, and this is one resistor, and I need second resistor, and next one I need, that is op amp. So I am keeping all groups and all families, and I am searching for op amp as 741. In multisim software, for op amp we search for 741. Okay, here it is my op amp. Okay, the next one I needed is ground. So sources, ground, click on OK. Yeah, ground is got it. Okay, for input I am choosing function generator. To see the output screen I am choosing oscilloscope, which containing two channels. Okay, now as we discussed that Schmitt trigger is a non-inverting. Okay, for convenience I am changing the sign convention of the op amp. Okay, I am inverted the op amp. So negative terminal of the op amp, the negative terminal of the op amp is connected to the positive terminal of the function generator, and the common is selected to the ground, and one terminal. Okay, let us see after. Okay, these both terminals are connected, and one terminal of the resistor is connected to the output of the op amp for positive feedback, and the another terminal of resistor is going to be the grounded, and the non-inverting terminal is connected in between the resistors, and the output is taken at sixth terminal. So the positive terminal of the channel A is connected to sixth pin, and the second negative pin is grounded. That means negative terminal is grounded. Okay, I can see here square wave output. For sine wave output, I am giving second channel to the input terminals. That means the positive terminal of the second channel is given to the positive terminal of the function generator. Then the function generator which produces sine wave will be resulted at the second channel of the CRO, and the negative terminal is going to be grounded. So in this circuit I am missing two functions. The main functions of the that means the main function of the op amp, that is voltage sources plus VCC and minus VCC. In power sources I have plus VCC, which I should connect to the seventh pin, and my VEE for the fourth pin. Okay, 741, seventh one is the positive connection, 4 is the negative terminal connection, fourth pin is the negative terminal connection. To reduce confusion, I am inverting the source and connected to the seventh pin, and VCC is changing to as 12 volts VCC, 12 volts plus 12 volts VCC, and VEE as minus 12 volts VEE, minus 12 volt VEE. Finally, my circuit is ready to run, but I didn't give an input to the circuit. So let us give the input to the circuit. 1 kilohertz for 20 volts. Here 10 volts is enough, because here VP, that means here we can see VP, that means for only positive peak it will be 10 volts. For negative peak automatically it generates minus 10 volts. Then overall peak to peak it will be 20 volts input. I am giving sine waveform as input to the circuit, and let us run the circuit. Yeah, the waveform is so bulky, so I am increasing the time scale, so I can see the both. Sine waveform and square waveform. So it might be little confusion. So I am grounding. That means here 0 resembles ground. If channel A is become 0, that means if channel A is become grounded, then the output at the 6th pin will be grounded. That means there will be no resulting output waveform. Okay, there will be no resulting output waveform. If I keep it in DC, the output waveform will be observed. If the second channel will be if second channel is grounded, that means if 0, that means resembles grounded, then the input sine wave is neglected. Okay, input sine wave is disappeared. Okay, let us see first plus VSAT and minus VSAT. Here we can see that this is the plus VSAT. Plus VSAT means this is the highest peak of the output square wave gives plus VSAT, and negative peak will give the minus VSAT. Okay, let us go to the okay, here we can see this will be the plus VSAT and this will be the minus VSAT. If I keep the one probe is at a plus VSAT and another probe at a minus VSAT, here we can see if one resembles, that means first probe, one resembles first probe, that means T1, which gives minus 11 volts as minus VSAT, and plus here second probe, that means T2, which gives 11 volts, that means the plus VSAT as 11 volts as plus VSAT. Here coming to the theoretical calculation, here we can see the UTP upper threshold point, that means R1 by R1 plus R2 into plus VSAT. Okay, without knowing plus VSAT and minus VSAT, we cannot get the values of UTP and LTP. So first we have to find out the plus VSAT and minus VSAT. As we seen in multisim run compilation, here we can see the minus VSAT as minus 11 volts and plus VSAT as plus 12 volts. As we considered with the theoretical calculation, plus VSAT as 12 volts and minus VSAT as minus 12 volts. Then 10 kilo ohm by 10 kilo ohm plus 10 kilo ohm, then 10 by 20 kilo ohm, that resembles 1 by 2 into 12 volts, which is 6 volts. And similarly 1 by 2 into minus 12 volts, which gives minus 6 volts. Okay, this will be the UTP and LTP. Okay, this will be the resulting UTP and LTP. Okay, the theoretical value of plus VSAT is 12 volts. Here we can write the theoretical value of theoretical value of plus VSAT equal to plus 12 volts and minus VSAT, which is equal to minus 12 volts. These will be the these are the theoretical values of the plus VSAT and minus VSAT. As observed nearly that plus 11 volts and minus 11 volts. This is a plus 11 volts and minus 11 volts. Yes, plus 11 volts and minus 11 volts as the output. Okay. And now we have to check the UTP and LTP. For UTP, okay, the theoretical UTP and LTP will be the 6 volts and minus 6 volts. UTP and LTP are 6 volts. Okay, here what I said, 1 upon 1, that means the square wave upon sine wave, which gives the UTP and LTP. Above the UTP, the sine waveform is rejected, and below the UTP, the the sine waveform will be rejected. Okay, let us see on multisim here. Both the waveforms are observed at a time. Here plus UTP is measured as the intersection point above the reference, that means the intersection point of both square waveform and sine waveform, which gives the UTP, that means upper threshold points. Again, I will make a one sentence that above the reference line, above the reference line, the intersection between the both square waveform and the sine waveform, which gives the upper threshold point. That means I am choosing this second probe and I keeping at intersection of both at intersection point. If I keep at intersection point T2, the probe T2, which gives the output voltage as 6.528, that means nearly 6 volts. Okay, upper threshold point is observed as 6 volts. If I keep below the reference line, the intersection point at below the reference line, I can observe that means T1, which observed as minus 6.55 volts. That means nearly minus 6 volts. If I check the theoretical values, which will be the plus 6 volts and minus 6 volts as the resulting UTP and LTP. So I will note the plus VSAT and minus VSAT, plus VSAT and minus VSAT, and plus UTP and minus LTP, plus UTP and VLT. Okay, VLTP. Later on, I will calculate the hysteresis voltages VHY, which is a difference between the UTP and LTP, which I got here is minus 6.5 volts and 6.5 volts, which is given difference between T2 and T2 minus T1, which is a 13 volts as my hysteresis voltage. But the theoretical hysteresis voltage is 12 volts. Okay, it will be equal. That means it is nearly and approximately equal to the hysteresis voltage, 12 volts. That means I got 13 volts. It is not a problem. That might be 1 volt or 2 volts. Difference will be occur while doing the circuit connections or anything, etc. Okay, let us see the transfer characteristics of Schmitt trigger. For transfer characteristics of the Schmitt trigger, I will choose in multisim software. I have an option that B by A. Okay, B by A or A by B. Both will give the transfer characteristics of a hysteresis. Both will give the transfer characteristics of a hysteresis Schmitt trigger, hysteresis voltage and Schmitt trigger transfer characteristics. Okay, I have here two probes. I think have you seen this here? This is the plus VSAT and this is the minus VSAT and this is the LTP and this is the UTP. Okay, this is the transfer characteristics of Schmitt trigger. Here we can see that this is the plus 11 volts and this is the minus 11 volts and this will be the 6.5 volts, minus 6.5 volts, and this will be the plus 6.5 volts, and this difference will be the hysteresis voltage as 13 volts. So these are the transfer characteristics of the Schmitt trigger. Let us see the observation again. Yeah, hence we can find the hysteresis voltages and plus VSAT, minus VSAT, UTP and LTP of an Schmitt trigger. That means upper threshold point and lower threshold point of an Schmitt trigger. Hence, the result, the operation of Schmitt trigger circuit using op-amp is observed in multisim software. And the values are observed. The values which are plus VSAT, minus VSAT, upper threshold point and lower threshold point with respect to that hysteresis voltage. Waveforms are drawn on graph sheet. To draw the waveforms on graph sheet, we need to occur voltages, and that means peak voltage, that means positive peak voltage and negative peak voltage with respect to the time scale. Then we can draw the waveforms on graph sheet. That is about Schmitt trigger.